The solar system is more than 4 billion years old. If we're to assume that it has always looked much like it currently does, that would seem to put a premium on stability. Yet, the Saturn system is very dynamic. The largest moon, Titan, is moving away from the planet, geysers on another, Enceladus, feed material into one ring, small moons are condensing out of the materials of other rings. So there are reasons to think that Saturn hasn't always looked like it currently does. One of the things that isn't likely to have been stable is the rings. Scientists have estimated their age as about 100 million years, based on interactions with the nearby moons and the color changes that accumulate over time in a high radiation environment. While there's some disagreement regarding the 100 million year figure, explaining their presence at this point in the solar system's history remains a challenge. Not content with that challenge, the team behind the new work threw in a second, Saturn's large rotational wobble, where its axis of rotation is over 25 degrees from being perfectly vertical relative to the plane of Saturn's orbit. That's too large to have been produced during the planet's formation. In this case, we have some ideas regarding how this might come about later in the planet's history. Saturn can enter what's called an orbital resonance with Neptune. Normally, gravitational interactions among planets average out over millions of years. But in a resonance, orbital periods line up so that specific configurations of bodies appear repeatedly. In this case, some gravitational interactions can end up being reinforced rather than averaging out, causing effects that build over time. In the case of Saturn and Neptune, a resonance could potentially influence the orientation of Saturn's poles. While the math works out, we haven't known enough about some of the details of the Saturn system to determine whether it actually has a resonance with Neptune. But thanks to decades of data from the Cassini spacecraft, we now have the data we need to narrow down uncertainties.